9.5, hyperbolas. Just like how ellipses start, hyperbolas start with this beautiful slide. Okay, now, relax. Easy. Easy. Okay? Hang tight. Everybody relax and calm down. Okay? Now, a hyperbola. If you look at it, you see this blue parabola like this? Okay. You see this blue parabola going like that? That's what a hyperbola is. Okay? It's a conic written in such a way that it basically forms two parabolas, either that way horizontally or this way vertically. Okay? So text. Summarize it, people. You guys are almost seniors and juniors in high school. You should be able to know how to ignore that. Okay? Like an ellipse, a hyperbola is the set of all points in a plane such that the absolute value of the differences in the distance of the distances from the foci is constant. Basically, what it means is this. There is a focus and a vertex. Okay? Differences of the distances from the foci is constant at all times. So this distance to here, this distance to here. On the other side, this distance to there, this distance to there. Okay? Kind of like parabola, right? Remember how the focus and directrix part of parabolas? Okay, your equidistance between the focus and the directrix. Kind of like that, it just happened twice now. Okay? Happened twice. Alright? Every hyperbola, you'll hear me say parabola instead of hyperbola like all day, so just get used to it, okay? Every hyperbola has two axes of symmetry. Transverse axis and the conjugate axis. You do not need to know, I don't think you need to know which one is which. Okay? Transverse, I believe, goes towards your vertexes on both. Yeah, transverse goes towards your vertexes, conjugates go the other way. Okay? But if I'm not mistaken, you don't need to know that. Just like ellipses, the axes are perpendicular in the center. Okay? The foci of the hyperbolas always lie on the transverse axis. I did just say that, just so you know, but you won't need to know. The vertices are the endpoints of the transverse axis. So the vertexes, the vertices, that's where the transverse axis ends. The co-vertices are the endpoints of the conjugate axis. So you can see, if you look at this table, you have V1 and V2 here and here. See that? Those are your vertex 1, vertex 2s. That's where it says here, labeled vertex. See C1 and C2? That's where your co-vertexes are, and they're on the other side of your conjugate axis. Okay? Yes, it is an ugly slide. Yes, there are a lot of moving parts. Stay with it. Okay? All right? Okay, equations of hyperbolas. These are centered at the origin, and more so than anything else, I give you parabolas or hyperbolas. I give you hyperbolas that you have to do all the different things with between using focuses, using vertices, and stuff like that. I give you centered at 0, 0. Okay? I give you centered at 0, 0. When we get to the equations that, not everything, okay? So whenever I get to that one that's like, oh, did you say this? No, I didn't say everything. I said most of it. Okay? You'll see when we get there. All right? Standard form of your hyperbolas look very, very similar to your standard form of ellipses. What's the one difference?
Subtraction.
It's a subtraction, not a plus. Okay? That is the one difference. All right?
Are we going to have like every single one of these like charts memorized for the test?
Nope.
Thank God.
I know. They're pretty sure I said that yesterday. Weren't listening, I know.
We didn't know that there would be more charts.
That's true. There's always more charts.
Why?
All right, your orientation in the horizontal column. Your foci, once again, are C units away from your center. Okay, you can see how you're centered at 0, 0 in this guy. So your foci are plus or minus C units away. Length of transverse axis, 2A units, just like how The length of your major axis was 2a units, just a fancy new name. Length of your conjugate axis, 2b units. Okay, so all that stuff holds true. All right. Now, I'm going to back up real quick. Sorry. I do want you to look at two pink lines here. See this diagonal right here? Going that way? See the other one going that way? What are those lines? Asymptotes.
I thought those were the axes.
Nope.
And I was like, what is happening? Okay, I thought
No, those are asymptotes, okay? These approach asymptotes. The equations to those asymptotes, when you're centered at 0, 0, if you're orientated horizontally, is y equals plus or minus b over a x. One positive, one negative, two lines, right? Okay, and you get that from b over a. Alrighty. You're vertically, if you look, they're very similar, okay? Obviously your foci then move up and down, not left and right. So that's why plus or minus c is in your y coordinate. And then you flip-flop your slope. It's a over b for your asymptotes instead of b over a. Okay? Besides standard form, I get here, let me put it like this. I give you guys what you need. Okay? Besides the standard form of it. That you have to know. Okay? But whether it's the length of the transverse axis, the conjugate axis, asymptote equations, it may be the ones that once we move off of being centered at 0, 0, it may be those, but all you have to do is plug in your center of 0, 0, and you get back to here. Okay? Everybody good with that? All right. Now, I don't know why I put that bullet. There are two axes of symmetry. We've said it like 5 times. Here is where this gets a little rougher. Okay? In the hyperbola universe, a, b, and c are related by c squared equals a squared plus b squared. Okay? The way the variables shake out, that's their relationship. Okay? C squared equals a squared plus b squared. So the way you remember the two is this. Ellipses, standard form has a plus in it. The relation equation it has a minus. With hyperbolas, standard form has a minus. Relation equation, a plus. All right? That's the easiest way I can tell you to do it. All right. Write the equation of hyperbola shown. Okay. You got vertices at 4, 0, negative 4, 0. Okay. You got foci between negative 5, 0, or at negative 5, 0, 5, 0. Okay. Step 1. Center. In this case, it's what?
0,
0,
0.
0. All right, won't always be 0, 0. Most of the time it will be, though. All right. Now, just like ellipses, you need your center, you need your A, you need B. You may need C, okay, depending on what you're given. All right? But you definitely need A and B. All right, so A. ABC. A is the distance between vertex and center. All right, which is also known as your what? A new word. Length of your transverse.
Wait,
Okay.
that's not the distance between the two vertices?
Transverse is vertex to vertex,
Okay.
which is A. Okay, which gives you the equation 2A from the slide before, yes?
You just told me A was distance from foci to foci.
Find A, B, and C. Okay, so A, you find it by getting the distance, your transverse axis, which goes from negative 4 to positive 4. So the distance is what? Distance is 8. Transverse is 2A that. So A is what? So A is 4. Okay. Now, B is your conjugate axis, same way as your minor axis from ellipses, yes? All right. Now you don't know your covertices though. Okay? You know your foci, though. So that's where you have to use your C. Okay, so C is the exact same way. It's the length from foci to foci. So from -5 to 5, or 2C is what?
10.
2C is 10, which means C is 5. All right. Your relation equation for hyperbolas is the Pythagorean theorem. So C squared equals A squared plus B squared. All right. So you get 5 squared equals 4 squared plus B squared, which is 25 and 16, so B squared equals? Did I say 14?
It's 41. One? I don't know. What?
25.
Sorry. It's 10.
So 9 equals B squared. Don't need it. You just need B. You need B squared. Okay. Now you got everything you need. What's your center? 0, 0. All right. This guy is orientated how? Horizontal. Okay. Pointing out, pointing up, left and right. So horizontal orientation. Okay. So that means x gets the bigger number. So x squared over a squared, which is 16, minus y squared over b squared, which is 9, equals 1. All right, number 2. The asymptotes for a vertical hyperbola are y equals 5/3 x and y equals -5/3 x. The vertices are at 0, 5 and 0, -5. Write the equation of the hyperbola. What's the first thing you should always do?
Find center.
Okay, actually something else. Because the last time you didn't have to because I gave it to you. Decide if it's vertical or horizontal, even though it tell you, or you figure it, or you sketch out a little picture to figure that out. Okay, bye. All right. So 0, 5, 0, -5. Okay. It also tells you it's a vertical one. Okay. Sometimes that'll happen. Sometimes it won't. Okay, and we know that these lines are going like that and like that, just from your general shape of a hyperbola. All right. Okay, good. Okay. Now that you have your picture drawn, first thing you do, center. Center's what? 0, 0. Okay. Center 0, 0. Okay. So, what are we missing?
Your A squared, B squared.
We're missing A, we're missing B. Because we need A squared, we need B squared. Ideas?
So what's the distance?
Oh, I heard it. Hold on.
You use the asymptotic equation?
Asymptote equations. Good.
Oh, isn't it right there?
Because it is literally
A over B.
right in front of you. Okay? Literally, it's right there. The only thing is, you got to recognize that it's vertical. That way you can figure out which one is A and which one is B. Okay? So you have to know that whenever you're vertical, your asymptote lines are y equals plus or minus A over bx. Which means that A is 5 and B is 3.
Isn't one negative though?
No. So you got everything you need. Orientated how? Vertically, so what gets the bigger number? The y. Okay, so y squared over 25 minus x squared over 9 equals 1. These, it does matter which order you put them in. Okay? Ellipses, it doesn't really. Hyperbolas, it does. Since the subtraction, right? Okay? Yes. Okay, now, this is the one that I will give you everything except standard form 2. Okay? everything. I'll give you the orientation row, I'll give you the foci row, vertices, coverts, equations of asymptotes. Once again, your ones that you're centered at 0, 0 are derived from this page. Okay, so if I give you one that's more helpful, it's these. Okay. The biggest change, honestly, is if you look down at the bottom, is your equations of asymptote line. A little more ugly. All right, a little more moving parts going on. But let's start at the top. Standard form, very, very familiar, yes. Okay, just like I said, it's ellipses, but with a subtraction. Okay, foci, h plus or minus c, which, distance from center to foci is c, vertices is a, coverts are b, going the opposite direction. All right, just like how ellipses went. And then, like I said, equations of asymptotes. Alrighty, they give it to you in point-slope form because you use the center point. Okay, which is hk, right? All right, so that's why they give it to you in point-slope, because you have to know what h and k are. I did that backwards. H and k. There we go. You have to know what they are. That we can plug them in. Now, whenever you do this, you'll eventually write that equation in slope-intercept, but you got to start it with point-slope. Write the equation of hyperbola in standard form. Oh, look, I did that for you. Identify the vertices, foci, and asymptotes. This is where we have some fun, folks. Okay, first thing. Center. Center in this case is what? 3, -2. All right, good. Step 2. Do your ABCs. Okay. Which are pretty simple, right? Okay. In this case, A is what? Oh, be careful. Oh, I said A. My fault. I thought I said A squared. A is 2. B is what? 4. Okay. So A squared equals 4. B squared equals 16. Which means, I don't need an equal sign there. Means A equals 2. B equals 4. Alright, now, you got A squared, you got B squared, you need to figure out what? You need to figure out C, okay? You still need to figure out, and this one you need C. Okay, you do. Alright, because we have the equation, now we're finding all the other extra stuff. So you need to find out what C is. So we know C squared equals 16 plus 4 from A squared and B squared, which means that C squared equals 20. Okay? And the reason we need that, because if you look back here on this page, we use C to find our what? Your focus, your foci. Because foci is the distance between, or C is the distance between your center and your foci. Okay? So what's C in this case? What? It's got to be decimal. 4.4. I think they keep it 4.7, so I'm going to do the same. All right? So C equals 4.47. Okay? Everybody good with that stuff that's up there? Okay? Okay. Now, 3. Next up, we're doing our vertices. All right? Now color coordinate the rest of these. All right? Your vertices, they are A units away. Okay? A units from your center. Okay, your center in this case is 3, -2. Okay? You're orientated horizontally, okay, because it goes first. All right? That's what I meant to say. Whichever one goes first is which way it's orientated, whether it's X or Y. The numbers underneath don't matter. Okay? That's why I should have worded this.
Okay, so we don't need the word F16 before now?
Hmm?
So we don't want to have 16 before now?
No. That was my goof. Okay? X goes first because it's orientated horizontally. That's what it means. Okay? Everybody good? Okay. Since you're orientated horizontally, Y stays the same, right? Okay, think about it. You're moving left and right between your vertices, between your center and your vertices. Okay, so Y doesn't change, your X changes. So your X changes by A units. So A was what? 2. Okay, so it should be 5 and 1. All right, so your vertices, 5, -2, 1, -2. Whoop. All right. Next up, your foci. Foci are C units from center. All right, foci, you're also moving which way? Left and right. So once again, Y stays the same. You change your X. All right, how much do you change your X by? 4 point. Okay, so you should get these to be 7 point. I got 7.47, -2, and -1.47, -2. All right.
Wait, how'd you do that again?
C is 4.47, right?
Okay.
My foci are C units from my center. So it's orientated horizontally. You move left and right, so you change your X value
Okay.
by 4.47. All right? Everybody good? All right, now, last thing you need. It doesn't say anything about your co-vertices, okay? Notice that? All right, so if it doesn't say anything about them, you don't need them. Last thing we need is your asymptotes. All right, let's do it in baby blue. Ooh, there we go. All right, now, your asymptote equation is this. Y minus K equals plus or minus B over A times X minus H. Once again, given to you. Okay? You have all the parts. You built it up to find all the parts, so just plugging it in. So Y minus -2 equals. Keep it plus or minus for now. All right. You got B to be 4, A to be 2, times X minus 3. Okay. Split it off now. Do the 1 plus and the 1 minus. All right, so Y plus 2 equals 2. That's 4 over 2, right? Yeah. Okay, X minus 3. That's 1. Y plus 2 equals -2. X minus 3 as your other. Distribute, subtract the 2's from the left. Make it Y equals slope-intercept forms. All right, so Y equals 2X minus 8. Y equals -2X plus 4. What do you do? 3 words.
Click the square.
Okay. Now, only thing you got to be careful with hyperbolas. Okay, and this is how when you're working one, you tell the difference between an ellipse and a hyperbola. You still go through, you group your x's together. we move over that 199. All right. You still group them, take out your 9. So 9 parentheses, x squared plus 126 divided by 9 gives you 14.
Excuse the interruption. This is Mrs. Wilbur. Can Dante Ray, Nicole Jones, and Mandy Caldwell come to my office after school? Thank you.
All right. Now, what do you need to take out of the y's? A negative 4. Okay? You got to take out a negative 4 out of the y's, which gives you a positive y squared and a plus 8y equals 199. All right. Fill in your parts. Okay, so a plus 49 here, a plus 16 over here. All right. Now, you guys have got to balance these. Okay, we're getting there. All right, so now, to balance these, plus 9 times what you added in, which is 49,
16.
plus 16 times what?
Negative 4.
-4. Okay? You guys have to make sure you balance it. A lot of you guys messed that up on your last quiz. Okay? Which you'll hopefully maybe get back tomorrow. All right? You should end up, I'm just going to tell you this one. Where I don't know what's at. I'll work it out. I'll pop it up.